Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we will be covering GCSE Physics, Conduction and Convection. Now this is quite an important topic because we need to understand how heat is transferred in order to understand some more advanced concepts in physics later on. So, without further ado, let's get started. Okay, so first of all, we need to understand what is heat. What is heat? Well, heat is the energy that particles possess. Heat is the energy that particles possess, the vibrations of particles. I will show you exactly what I mean. So heat equals to particle vibrations. Now, if say particles are cold, like the atoms, something's cold, well then atoms of it are going to be cold too, right? What does it mean? What does it mean on the atomic level? What does heat mean? It means that these particles do not move much at all. They sort of vibrate, they shake about, but not much at all. So this is what happens in a cold situation when it's cold. Just like here, they're moving about, they're shaking about, but not much. So this is cold. However, if we heat them up, we put them on a stove or a heating block or even water bath, anything. If we heat these particles up, what happens? They gain more energy. Particles gain more energy. So as they gain more energy, they start vibrating and moving around more. So that's what happens when they get hotter. They move around much more. They vibrate more, they move more. So that's when particles are hot. So that's the fundamental understanding of heat. This is essentially how heat works. And on basis of this, we can start understanding how heat is being transferred from one object to another, or from one area to another area. Okay, so today we will cover 2 out of 3 transfer methods. Today we will cover conduction and convection. Now, there is another way. The particles can be the heat can be transferred via radiation. But this is something we'll cover in another video. This is a whole topic unto itself. So we will today cover conduction and convection. So let's kick it off with conduction. What is conduction? Conduction. That's how you spell it. I'm gonna underline it for you. Now, conduction is mostly about heat transfer in solids. So, for example, if we hold something in our hand, then we will warm it up. If you hold a coin in your hand for a long time, it will eventually get warm because of conduction, because of the heat undergoing conduction and being transferred from your hand to that coin you are holding. How does conduction work? Well, as we said here, the particles vibrate. So, best way probably to show it is like this. So, we have a bunch of particles here, like this. And these guys vibrate. They vibrate, as we explained. They may be cold at the moment, and they vibrate a little. Now, if we were to heat up this end, this is an object, and if we were to heat up this end of an object, then these particles would start moving up, vibrating more. They would start vibrating much more. They would move around and they would vibrate much more. Now, what happens if these particles start vibrating a lot? So here we have hot. Now, So this end of an object is hot because these particles are vibrating a lot. Now, what happens is we have all these particles here in this solid, like this somewhat. Now, what happens is when these guys move around a lot, they bump into these guys. They collide with these particles. Now, because they collide with these particles start moving around too. Just like this. Maybe not as much as these guys do, but they start moving around too. And they collide with these particles, and so on. And these guys move, they collide with these guys, which collide with these guys. And all these particles start vibrating. These collisions essentially transfer the energy from one particle to another. So these collisions between those particles are actually what heats up this object. Now it also explains why this end will be hot. However, if we do not actually heat this end will be colder. Because after a while, yeah, it can heat up too, but initially this end will be colder because not all energy will be transferred to the next particle, to the next. So it's becoming less efficient as you go. But we can, that's one way we can transfer heat energy. Now, what is important is, another term is important, thermal conductivity. I'll write it down for you. Thermal conductivity. Okay, so another important term is thermal conductivity. Now, what does it mean? Thermal conductivity means ability to conduct, essentially. Long story short, that's what it means. Ability to conduct. Now, some objects have a very good thermal conductivity. So, some objects, such as metals, will have very good thermal conductivity, which is actually why, if you touch a metal for the first time, it feels quite cold to touch, because it conducts that heat away from you. It conducts it away from you. It takes that heat from your hand or finger, and it conducts it away. Which is why metals can often feel a bit cold in the beginning, until you heat up the entire object. It feels cold. Whereas low thermal conductivity, for example, could be styrofoam. Styrofoam is a good example. Because, that's what we use as an insulator. This is a good insulator, whereas this is a good thermal conductor, and this is a good thermal insulator. So that's how conduction works. Now, let's move on to another way we can transfer heat energy, and that is convection. I'll write it down for you here. Convection. And that concerns mainly liquids and gases. Now, what is convection? It's, as we said, conduction works by particles bumping into each other. One particle bumps into another. But what happens if we heat up a liquid? What happens if we heat up a gas? Convection cannot occur. Convection current can occur. But what is it and how does it work? Well, let's go back to what is heat. Now, if we have particles like this, and they are not moving around much, they're just sort of vibrating like this, they're not moving around much, it's cold. Now, again, if we have particles that move around more, they move around like this, then it is, in fact, hot. Why is this important? Why am I telling you this again? Well, because we need to understand that when a liquid or a gas gets hot, it becomes less dense. So, hot equals less dense. Now, why would it be less dense? Why would suddenly, if we heat up a liquid or a gas, why does it just magically become less dense? Well, this is because if you look at this, when we have particles moving around a lot, then they clearly cannot be as tightly packed as these guys. These guys are moving too much. They cannot be as tightly packed as these guys. So for any given volume or an area, we will have less of these particles because they're moving around. They sort of are not as tightly packed than these guys. Here we will have much more particles in a single, unit of volume or an area. We will have much more particles because they're more tightly packed because they're not moving as much. Now, if we have particles that are more tightly packed, well, we could call this that these particles, the density of these particles is higher, so they are more dense. Whereas if we don't have particles that are tightly packed, because they're moving around so much, they are less dense. So that explains a bit of the theory behind the air density. Why am I telling you that? Because convection is all about density. It is all about density. Because convection is a transfer of heat via forming a current based on density. I will explain a convection here. The best way to explain this is like this. We have a room that looks somewhat like this. And here we have a radiator. Now this radiator is heating up. The surrounding air. So what happens when air heats up? Well, when air heats up, it becomes less dense. Now what happens if we have less dense air here, whereas we have a very dense air everywhere else? Well, the dense air falls down, whereas the hot, less dense air rises. You may have noticed this, for example, if you say go on a hot day, go on the top floor of a building, you will see that upstairs it almost always is hotter than downstairs. This is because of convection. Okay, sorry guys, I had some technical issues, but anyway. So here we have a room with a radiator that heats up the room. Now, what happens when the radiator heats up the air around here? What happens is that air starts rising. Because it heats up, it becomes less dense and it starts rising to the top because it's less dense than the air around here, which pools at the bottom of the room. Now, because the air has risen to the top, what happens is that this air here needs to be replaced somehow. So, therefore, it's replaced with cold air from the bottom of the room. Now, because the cold air is replacing it, now it's being warmed up. So now the cold air keeps rising to the top as well. That has been warmed up now. And then this pushes the air along here. And then the air here starts cooling down because it's quite far away from the radiator. So it starts falling. Like this. And because this air keeps being drawn in by radiator to be warmed up and pushed up, this air starts coming back down this way. So what we get here is a current forming in the room, and that is called convection current. Let me put it down for you. Now, this is literally how radiator is able to heat your room. That's how your one single radiator is able to heat your entire room, because it keeps warming up this air. It keeps leading to that whole air exchange that allows it to warm up all the air in the room using convection. So this is how convection can be used to transfer heat. Now, another important thing to mention is that convection is a way to transfer to transfer heat by exploiting changes in air density due to heat. Now, also convection is actually partially involved in weather, where on a large scale, where it may cause winds because the air is rushing from a colder place to a hotter place due to change in density of the air. It's rushing from one place to another place, which is why we sometimes get winds. This is not the only way this happens, but this is one way it can happen, via convection. So that's interesting. And this is it for convention. So this is it, guys. Thank you very much for watching. Every time you watch these videos, I really appreciate it. Thank you very much. And if you want to stay up to date on daily videos on maths, sciences, and some university level biomedical sciences videos, hit that subscribe button below. If you liked the video, don't be shy. Give it a big old thumbs up. And see you next time.